Okay, this is the second of the magnets videos, the first being over magnets and magnetic fields, this one being over electromagnetism and its uses. So what is electromagnetism? Well, it's basically exactly what it sounds like. It's an interaction between electricity and magnetism where basically one can create the other, right? Electricity can create magnetic fields. That's what's happening in this picture here. The wire has a current running through it as denoted by I, and then it's creating a magnetic field in the area that's B. Of course, it would be creating it all the way down the wire itself. So let's talk about it in a little more concrete sense, like what it would look like. Well, a solenoid is a coil of current carrying wire that produces a magnetic field. Right now, this is a very large solenoid as it's a lot of wire. And when you plug this into some kind of device that's going to give you electricity, either an outlet or a battery or something like that, what it's going to do is it's going to carry a current on the wire. As it carries a current on the wire, it will also, as a byproduct, create a magnetic field. So when you plug this thing in, basically it will become a very large magnet. The name is just what they decided to call this thing, instead of just calling it a giant bundle of wires wrapped around a tube. So that just seemed very long, so they said let's give it a name. So we'll call it a solenoid. Now, electromagnets is a solenoid with a ferromagnetic core. If you remember, a ferromagnet is anything that consists of iron, nickel, or cobalt. So when you put a piece of iron, nickel, or cobalt inside of a solenoid like so, it becomes a very strong electromagnet. Why electro? Because it's going to have a current running through the wire. When you throw the magnet or the ferromagnetic material inside of it, you have electricity from the current, magnet from the ferromagnet, boom, electromagnet. Makes a very, very strong magnet. Can be turned on and off. Remember in class I talked about I showed the example of the crane carrying the crane on the train tracks that picked up the piece of metal, and it was able to drop the metal whenever it wanted to by cutting the current off. There's some other electromagnetic devices that we use on a daily basis, but we don't really, probably didn't really know they were electromagnets. Galvanometers, device that uses a solenoid to measure current. Used in things like fuel gauges. It doesn't have to be a fuel gauge, but any kind of like gauge device typically is used with this. Got a great diagram on page 467 of your book, if you want to check that out. Also, electric motors. These are basic devices you've seen on toy cars and stuff like that before, because you put a battery in it, it will start, makes an electromagnet turn an axle, right? It makes the wheels turn or something like that. In class, I showed the little simple motor thing with the wire spinning underneath the magnet with the D battery underneath it. So it doesn't spin if you take the battery out. The secret is you have to have the current going. Speaker's another electromagnetic device. Contains a solenoid placed around one pole of a permanent magnet. It's kind of what you can see down here in this bottom part. You actually can only see the magnet and the covering, but there's a solenoid going around it, and as the current changes, the magnet moves more or less. It can move, if the current's going this way, it'll move out, and if the current's going this way, then it will pull in. So very cool video on deconstructed on loudspeakers. Check it out if you ever get a chance. I showed it in class, but it's definitely a cool video. All right. Generator. Generator is the opposite of an electric motor. It's the best way to think about it. So going back to electric motor, device that uses an electromagnet to turn an axle, right? So you turn electricity into mechanical energy, basically. In this case, a generator turns mechanical energy into electrical energy. So it spins a magnet, and as it spins a magnet mechanically, it turns into a current, which this is what a generator is here. You put gas in it, you crank it up, the little engine spins a magnet around, and what happens is you generate electricity, or you make it. You can plug in a couple things here and it'll work. Right? This is a large-scale generator, and if you'll remember, this is from a hydroelectric power dam. I showed a video in class about how that was kind of made. Very, very cool stuff, electricity. A couple other generator examples. This is a hydroelectric generator, and it's a very, very large magnet. Here you can see a cross diagram of it. Water comes in, so it's mechanical energy, right? Remember KE to PE and all that. Comes dropping down in here and it spins the blade. Well, as the blade is spun, turns the magnet. Magnet is creating or generating electrical energy. Also, this is a windmill. Windmills do have the same thing. As the wind blade turns, it turns this drive shaft, which is connected to the generator, and the generator thereby turns electricity or creates electricity, generates electricity. Transformer. Device increases or decreases voltage and current of two linked AC currents. It's not a cool robot. They are transformers, but the transformers that you use on a daily basis are much more useful. Granted, they don't save the world and so forth, but they do allow electricity to be used in your house. So let's look at the two different types. I showed a video on this too. There's two basic types of transformers. A step-up transformer and a step-down transformer. And a step-up transformer does exactly what it's saying. Increases voltage or steps up the voltage by adding additional loops of wire. So when you have wire coming in, when you have wire coming in here, here you'll notice the wire has 5 turns. It's bringing 100 volts in at 10 amps. Well, what happens here is as it transfers over the transformer itself, there's more turns. What happens is it steps up the voltage or increases the voltage. So where you had 5 turns, now you have 20 turns. So what did that do? It increased it times 4. 5 times 4 is 20. 100 times 4 is 400. Makes a lot of sense. So what are you losing? You're losing current. But that's okay. It's at 2.5 amps. Now, you don't need to know the calculations. You don't need to know the math. You need to know that if it's coming in with a small voltage, it can leave with a high voltage. Step up transformer. So you come in with a small voltage, you come out with a high voltage. This has everything to do with the solenoid. Coils of wire carrying current. Now, the step down transformer is exactly the opposite. Makes complete sense. It decreases the voltage by subtracting loops of wire. In this case, you have 50 turns coming in. Well, you have 10 turns coming out. So what happens? You divide it by 5. So you have 1,000 volts come in, divide by 5, you get 200 volts. So that's exactly what it is. It's as simple as that. So decreases voltage. Step down transformer decreases. Step up transformer increases voltage. I mean, these things seem pretty self-explanatory to me. I love these diagrams. They're great diagrams because they help you see how it really works. So anyway, I believe that is it. That is it. All right, folks, I hope you find it useful, and I will see you in class.